Okay, so now we're at a point now where the machine has been wired up. We've got cut control loaded onto our controller, and we've got it powered up. And at this point, we can actually jog the machine around. Before we jog the machine around, I just want to remind you that we haven't done any of the cable management yet. So as we jog the machine around, just be mindful of where the cables are laying to make sure that they don't get pinched or damaged in any way. We're going to take care of doing all the cable management after we get the limit switches on, but for now, it's acceptable the way it is. So if you got your jog pendant, I'm just going to do a brief overview of how to jog the machine. You can do it one of two ways. One is you can use the arrow keys on the keypad. So I'll jog left, which would be the negative X direction. And you'll see that I'm jogging at what is 100 inches a minute. If I want to jog slower, I can select a slower feed. In this case, it would be 10 inches a minute. So I'll go ahead and you can see that it's a much slower jog speed. And similarly, I can push the up arrow and I can jog in the Y direction. Now, if you don't have a keypad, you can just, if you have a touch screen, you can just touch the touch screen, or you can click on those buttons with your mouse. The reason that we need to be able to jog here is because at this point in the process, we are going to make the Y-axis rails parallel to one another. It's really easy to do. You're going to need a 3/16 Allen head wrench, and all we're going to do at this point is come back here and just break loose the screws that secure the right-hand Y-axis rail to the upright. We're just going to break them loose. And then what we're going to do is jog the Y-axis to the other end, and that'll actually auto-align the Y-axis rails, and it'll make them parallel. So I'm going to select rapid motion, and I'm going to jog it all the way to the other end. And the Y-axis rail will actually move as you're doing this. It'll auto-align itself. So I'm going to jog it all the way up to the point where I haven't covered up the socket head cap screws, and I still have access to them for tightening them. So I'm going to do that now. And that's it. So now we've got aligned Y-axis rails. The next step that we're going to do is install the limit switches and the limit switch hard stops for the Y-axis and the X-axis. So I'll go over that now. So the machine comes with 4 different limit switches. I'm just going to jog the X-axis over here so we could take a closer look at it. But the machine has 4 limit switches. There's one on the Z-axis, which we pre-install in our factory, and that's location is here. Obviously, it doesn't have the cable connected to it. But then there is one on the X-axis, and then you have 2 on the Y-axis, so Y1 and Y2. Off camera, I've already pre-installed the 3 limit switches that you'll be responsible for installing. You're going to need, to secure the limit switches, you're going to need the BAG 19 M2.5 socket head cap screws. And for the Y-axis, that uses the same screws. And then additionally, I installed off camera the threaded rods. That's so the threaded rods are bag number 22. There's one on each side. And then you'll also need bag number 21. That's these 1/4-20 jam nuts. Again, there's one on each side. So these threaded rods, they get screwed into the hole. And what really works well is to use use both jam nuts, double nut it, and then you can use a 7/16 wrench to tighten that threaded rod into the casting. And then you can remove the jam nuts and install them where they go. Additionally, you'll need these Y-axis limit switch adjustable stops. Those come in a baggie in your miscellaneous box. And you'll notice on the X-axis, there's already a pre-installed bolt and a jam nut from the factory. So this is your adjustable X-axis stop. You'll notice on the XY motor mounts where, again, there's 3 of them, one for the X-axis and then one for each of the Y-axis locations. There's actually 3 holes that, on top of the limit switch. So you want to make sure that the limit switch is oriented and positioned correctly. So on the X-axis, you want the trigger to be facing to the right, and you want it to be installed in the left two threaded holes, just as shown here. That ensures that the trigger is going to make contact approximately in the middle of the bolt that acts as the adjustable stop. Then for the y-axis, again, these are the same mounts, so there's 3 different holes. For the right-hand side, so this would be Y1, you want the trigger to be kind of facing inboard towards the center of the machine. And you want to use the 2 rightmost tapped holes to secure it. The reason this is important is because it puts the contact point where it's supposed to be on the stop. And so if you have this incorrect, it won't actually contact where it's supposed to on the stop, and it'll be readily apparent to you and what needs to be fixed. On the other side, you just have a mirror image. We're using the 2 leftmost screw holes, and the trigger needs to be facing to the inboard of the machine. So that's the installation of the parts. You could just screw the jam nut and the stop onto the bolt just like this, and we're going to go ahead and fine-tune the location, or I guess the adjustment of these, to ensure that we're using all of the travel available to us, and we're also going to square the x-axis to the y-axis, and we're going to be using those stops to achieve that. So for this next step, we're going to set the limit switch stop for the x-axis. This is actually a lot easier to do than the y-axis. It's very simple. First thing that we're going to do is just back off this jam nut, and all we're going to do is just screw this bolt in until about 1 inch or so is protruding from the edge of the casting. We're just trying to get it out of the way for now so that we can basically jog the x-axis all the way up to its hard limit, and then we can extend this bolt out into the appropriate distance to trigger the switch. So step number 1 is you're going to jog the x-axis all the way up until it hits the hard stop. So I'm going to do that now. And it's not going to hurt anything to jog up against the hard stop. It makes kind of a weird stepper motor noise, but it doesn't hurt the machine at all. It doesn't hurt the motor. It doesn't hurt the control. So now I'm all the way up against the hard stop. Now I'm going to just use my fingers to back out this bolt. You'll hear the switch click. So if I do that again, I want you to hear that again. I don't know if you can hear it on the camera, but when I do this slowly, you'll hear it switch right there. I'm going to keep going, keep extending this out until the switch has basically bottomed all the way out. And I'm going to back it out maybe 1/2 of a turn. So there's a little bit of additional stroke left, but not much at all. That's where I'm going to set my jam nut. So I'm going to hold the bolt stationary, and I'm going to screw the jam nut out. And then I'm going to use a 7/16 wrench to tighten the jam nut. Just like that. Now, if I go and back off of there and I run against the hard stop, it'll protect the switch. So the switch can't ever be broken, and I'll demonstrate that now. See how it doesn't affect the limit switch? That's the objective that you're aiming for when you do this, and it's the same on also doing the y-axis, which we'll move on to doing now. So really the first step in setting the y-axis limit switches has nothing to do with the limit switches at all, and it has everything to do with making the x-axis gantry square to the y-axis. The reason the limit switches are a part of that is because this machine comes with what's called auto gantry squaring. It's part of the software. And what happens is if the gantry ever comes out of alignment with respect to the y-axis, you can home the machine and it'll go and touch the limit switches and it'll auto square itself by basically, it'll touch one of the limit switches and stop, and then it'll come and touch the other limit switch and stop and restore the squareness that was originally set when the limit switch stops were fine adjusted. So again, the first step that we're going to do is make the x-axis square to the y-axis. You're going to need a few tools to do that. First is you're going to need a 3/16 Allen wrench, and I did this off camera. But what you use this for is, as you know, there's 4 bolts that secure the gantry to the y-axis carriages. You're going to use this to just break loose the front left bolt, the front right bolt, and the back right bolt. Those are just going to be broken loose. The back left bolt is going to remain tight. If I come to the other side, you're going to do the same thing, except the front right bolt is going to remain tight. And the remaining 3 are going to be broken loose. So the ones we're breaking loose are the back right bolt, the front left bolt, and the back left bolt. So the gantry is being secured to each of the y-axis carriages at this point by 1 bolt each. The front right bolt on the right-hand side, and the back left bolt on the left-hand side. What that's going to allow us to do is the gantry is going to be able to, we're going to be able to make adjustments of the y-axis carriages to influence the squareness without causing anything to bind. The next tool that you're going to need, it's really a set of tools, is a block of known squareness, such as a precision machinist square, or in this case, I've got a 1, 2, 3 block that we are going to use in conjunction with a test indicator to compare the squareness of the machine to the squareness of your precision block. Again, to do that, we need a dial test indicator. This is the one that we offer on our website. It's got 5/10 resolution, plenty good for this. One note about the size of the block, bigger is going to be better here. We actually were considering doing this video with a 2-4-6 block because obviously that's bigger than a 1-2-3 block, but most people at home are probably going to have a 1-2-3 block, so we decided to set it up with doing it this way. So what we're going to first do is take our indicator base, and we're going to position it on the side of the spindle cover, just like that. And the first thing that we're going to do is we're going to sweep along the y-axis direction of this block. Now I've got the short side of the block aligned to the y-axis and the long side to the x-axis. It's not super critical. This is my preference to do it this way. You can really do it the other way. It doesn't affect anything, but this is just how I like to do it. So I'm going to jog the gantry up to get the indicator into position for sensing along that edge. Then I'm going to position the indicator. And you can actually jog. You can use the machine set to a slow jog speed or 1/1000th increments to basically fine-tune the position to get the indicator exactly zeroed where you want it. So I've got it set to 10 inches a minute jog speed. Now I'm touching. I'm going to shift it to 1/1000 increments, and then I'm going to zero this out. Pretty much right there. So you'll notice also that I've got a toe clamp clamping this 1-2-3 block down. I don't have this thing tight. I've got it basically finger tight. It's just applying a little bit of pressure so that when I come and knock the block one way or the other, it's controllable. So you're going to want to use like a little mallet or a little rubber-faced hammer to tap this into position. But our goal here is to sweep back and forth in the Y direction and adjust this block until our indicator is reading 0. So no movement of the indicator. So I'm going to go back and forth here. Oops. So that's a continuous jog. And you can see here, very, very little movement. That's because off camera, I already set this up. But you're going to need to adjust the block until that is running as perfect as you can get it. Certainly want it to within about 5/10. Now that I've got that set, I'm going to move the indicator so I'm sensing along this face. So I'll do that now. Set to 10 inches a minute. So there's 0. Now I'm going to jog along the X direction and see how our error is looking. So it looks like I've got a little bit more than 5 thousandths of error from over a distance of 3 inches. So what that means is that this point right here, so the indicator, if the needle is going clockwise, it means the block is moving towards us. If it's going counterclockwise, that means the block is moving away from us. So I know now that I need to go and make an adjustment on really either my left hand ball screw or my right hand ball screw to correct this. But I'm going to make all my adjustments on the right hand ball screw. Next step is you're going to want to shut the power down to the machine, and we're going to disconnect the Y2 motor cable from the box. That will allow us to go ahead and manually turn the ball screw by hand to make a correction on that misalignment error. So I'll go ahead and do that now. Okay, so I went ahead and I disconnected the motor cable for the Y2 stepper motor. The Y1 motor is still connected, and I went and powered the machine back on. So now I've got holding torque on the left-hand side. And on the right-hand side, I can manually rotate this ball screw, and if in doing so, I can change the angle of the gantry relative to the y-axis. So I'm going to go ahead and sweep the block again and see what my error is, and then I'm going to make a correction with the ball screw and then see what does that correction do? How did it influence my reading? So I'll go ahead and just sweep back and forth. So there's 0. So I'm going to just go ahead and rotate the ball screw manually by hand until the indicator is reading 0. And we'll give it a try there. So again, I was using my hands to rotate the right hand y-axis ball screw, and that motion is what influenced the indicator the way it showed on the camera. So it looks like now I've got about 4 thousandths of error. So that means I need to keep going in the direction that I made my original adjustment. So we'll try that there. As you can see, the error is getting smaller. This looks like it's probably going to be about 3 thousandths of error. So I need to keep going a little more. Getting closer. That's maybe about 1.5 thousandths. It's really important to take your time on this step because the accuracy with which you perform this operation is going to determine how square you can make features on the machine, how accurately the machine will place hole locations and feature locations relative to each other. So very important to take your time here. A little bit more. Looks like I'm within maybe 6 tenths or so here, We go a little more. So it looks like I'm within about 5/10 there. I maybe go just a touch more here. That looks pretty good there. So I'm going to go ahead and use my wrench here, and I'm going to tighten up the bolts that secure the gantry to the Y-axis carriages. And then I'm going to plug back in my Y2 stepper motor. So now I'll have both motors powered up and my gantry fully secured back to the Y-axis carriages. Really important, make sure that when you're plugging and unplugging motors, you turn the power off when you're doing that. So I'm gonna turn the power up to the machine, plug the Y2 motor in, turn the power back on. After that, I'm gonna come back and double check to make sure my alignment is still good. And then from there, we're gonna go and set our limit switch stops. All right, so I got all the gantry bolts back up and tight now. I powered off the machine, plugged in the Y2 motor. Now both of them have holding torque. And just as a sanity check, I just went back, after doing that, I went back and I swept the block again. And I'm within probably 3/10 of right on the money there. So that's gonna be good enough for us. So I'm gonna go ahead and pull my indicator off and get it out of the way. And then now we can move on to setting up the limit switch stops for the Y-axis. The first step in doing this is we're going to jog the gantry all the way up to, but not touching the hard stops on the XY motor mounts. And we don't want to just drive this up and then hit those hard stops because the machine's you're gonna get missteps, and that's gonna totally throw out the alignment of the gantry relative to the Y-axis, which we don't want to do. If we do that and we miss steps, we're gonna have to come back and do all this over again. So I'm gonna use my keypad and I'm gonna jog it up to there, and I'm gonna just inch my way up little by little to get them as close as I can, but without touching them. And you'll see how I do that here. So I'm going to just set up to rapid move up to the back. And I'm just looking at both sides, and I'm going to see which one's going to hit first, because one of them will hit first. So now I'm within maybe a ½ inch. I'm going to switch over to 10 inches a minute. And I'm going to jog it closer. I'm just checking to see both sides, just little by little, which one's going to touch first. So it looks like this one on the right-hand side is going to be the one that's going to touch first. So that's what I'm going to focus on. I'm going to switch all the way to 1 inch a minute here. I'm going to keep jogging until I get close. And I'm within about a 1/16 of an inch, and that's going to be close enough for our purposes here. So the next step here on these limit switch stops, you'll notice that the way that we design them, there's actually a protrusion or a spigot on the face of it. That's actually additional protection for the limit switch, so that it prevents, even if you do this step wrong, it'll protect the limit switch. So what I'm going to do now is I'm going to just slowly rotate this limit switch, stop, and I'm going to just listen for a faint click from that limit switch. And once that occurs, I know that I've got this set correctly. Again, take your time here because it's important. And you can also redo this part. If you think you overshot the click, you could just back up and then do it again. But our goal here is to get as close to where the click occurs and set it there. Right there. So that's right where it clicked. And then I'm going to just carefully, without rotating the thumb nut, I'm going to back this jam nut up until it touches. And then I'm going to get some wrenches and I'm going to hold on to the flats on the stop and then tighten that jam nut. Really important when you're doing that, make sure that you don't inadvertently rotate the stop, otherwise it'll affect the accuracy at which the limit switch has been adjusted. So I'm going to go ahead and get my tools and do that. So I used my 7/16 wrenches to tighten the jam nut on the limit switch stop on the right hand side, and then off camera I went and I adjusted the stop on the other side until the limit switch clicked. Then I set the jam nut, used my wrenches to tighten it. So at this point what we're going to do is check to make sure that the limit switches are both switching at the exact same time. So we're going to listen for clicks when we jog into them and make sure that that the clicks occur at the exact instant. So we want them to click at the same time instead of click, click. So that's what we're going to look for here. So I'm going to use my jog pendant and I'm going to jog off of the limit switches about 40 thousandths. So I'm going to use a jog step of 10 thousandths and I'm going to click it 4 times. And I heard my switches delatch. Now I'm going to jog in about 20 thousandths. And then I'm going to switch to 1 thou jog increment. And then I'm going to just go 1 thou at a time. And I'm going to listen for the limit switches clicking. The goal is to have them click at the exact same time. But if they click 1,000th apart from each other, that's good enough for this. So I'm going to go just 1 thou increments and listen for the clicks. And I got a click on this limit switch. I believe I heard a click over there too. I'm going to jog it one more time and see. Yep. So I already got a click on both sides. That means my limit switch stops are perfectly adjusted. And now I'm going to be able to have confidence that my x-axis squareness is going to be perfect. And if something happens in a project, if I crash the machine or stall one of the axes, it's a simple matter of homing the machine, and it'll go and it'll auto square the gantry back up to perfect squareness as I have it here. The next step is going to be to get your limit switch wiring harness, get that plugged in, and then wire it up to the box. Okay, so I've got the limit switch wiring loom here. You'll notice that there are 4 connections on one end, and then there is a connector on the other end. This is the side that gets plugged into our electronics box. And then the other connectors get plugged into the various limit switches. You'll notice that these are conveniently wired. In this example, that's the Z axis. And then we've got Y1, Y2, and then the X axis right here. Want to make sure we don't inadvertently plug these into the wrong limit switches. I'm going to go ahead and just do the X axis to show you guys how it's done. And then off camera, we'll go ahead and do the other 3 axes. So really nothing to this. It's a simple blade connector. You just want to make sure you get the blade into the connector and not underneath the connector. So I'm just going to go red to red here. That. Just like that. So these are obviously very small wires, fairly delicate. Until we can get to the cable management steps, just make sure you take care not to yank on these or pull on them in any way. So we'll cover how to strain relief these in the next videos, but I'm going to go ahead and finish up wiring the rest of these, and then we'll get this plugged up to the box. All right, so all that's left is to plug the limit switch cable into the box. There's a port that's labeled limits. It's just a simple matter of lining up the key on the connector and installing it. So that completes all the wiring on the machine. The only thing that's left is do all the cable management, which is going to come in the next video. Thanks for watching.